In the first video, we cover the different features of BizDoc. In this video, we will cover the basics of implementing BizDoc from a developer point of view. Before we begin, there are a couple of things that need to be in place. In addition to Visual Studio, BizDoc requires Node.js and .NET 5. In addition, we recommend installing .NET EF CLI. The technology used when developing BizDoc app includes .NET for the web app server, Angular with material design, and Xamarin for mobile app if needed. You should familiarize yourself with programming concepts such as link, entity framework, dependency injection, RxJS observables, and reactive forms. Let us get started. BizDoc is installed as a Visual Studio extension. Go to the Extensions menu and search for BizDoc. Once installed, close and reopen Visual Studio. Go to New Project and select BizDoc as the template. The new BizDoc project has reference to two packages: NuGet, which provides the backend server functionality, and NPM, which is responsible for the front-end user interface. If we look at startup.cs, we will find two methods that link to BizDoc: add BizDoc and use BizDoc. Additional methods add additional functionality. Go to NuGet website and search for BizDoc for support packages. In Angular app module end, we will find a reference to the client-side module, BizDoc module. The for-root method accepts different settings to control client-side behavior. BizDoc implementation can be categorized into two parts, server-side and client-side. While the server-side runs the business logic, the client-side provides the user interface. The client-side negotiates with the server-side using APIs. We write the server-side code in C# and the client-side using TypeScript and Angular. If a mobile app is added, we will commonly use Xamarin. BizDoc implementation breaks down into components. All component has a server-side class. Some components have a corresponding client-side. The most common component is a form. A form consists of a server-side code written in C# and a client implementation written in TypeScript. Form backend class inherits from form base, while the Angular component implements form component. It is recommended you keep coding conventions on both languages. When a document form is being presented, the onBind function on the client side receives the form data. When a form is saved, the update method is called on the server side, allowing the backend code to intervene. A second common component is the report. It too has a server-side class and an Angular component for the client side. The server side inherits from report base, while the client side implements report component. When running the report, the populate method is called, passing results to the onBind function on the client side. Note that while reports must have a server-side class, the Angular side can be implicitly interpreted by BizDoc. A server-side component may have more than one client-side component associated with it, and a client component may serve more than one server-side component. For example, some dashboard widgets have more than one backend implementation, while others show different layout to the same server-side component. The binding of the two is done using the template attribute on the server side and the @BizDoc annotation on the client side, passing the same value. You can switch between implementations or provide a custom one by setting the type and template in the configuration file. When planning a component, the most basic step is to define its data model. Data model will describe the properties of the component we wish to design. We annotate the model in a way that allows BizDoc to interpret document information such as subject and value. While model is maintained as JSON, it is also used as an XML for formatting emails using .xslt. Note that the XML has some limitations, as the model needs to be serializable. The model can also be used as an EF model, instructing BizDoc to save data to one or more database tables. This is done by annotating the class or classes with table, line, and documented attributes. Use not mapped and ignore to skip properties which you do not wish to store in the database. A unique property value is the one driven from value resolver, which allows setting its value from a different place. A behavior common to both Angular and .NET is the use of dependency injection. A backend component can consume, for example, the store service to access the database. In the same manner, it may consume any registered service provided by .NET. An Angular component on its end may consume, for example, the cube service to query BizDoc cube and present data as chart. In the same way, it may consume common services, such as the HTTP client. For the complete list of available services, consult documentations. Form Angular side uses form group to manage its model state. Refer to Angular and Angular material to learn more. Once we covered the basics of forms, we can move to adding more advanced features. These include distinguishing between form state, compose, and preview mode using the view mode. Adding permissions to parts of the forms to different user roles, accomplished by managing the rules section of the form configuration. We may also add tags for displaying version changes, as document may have been modified after it had been rooted. We can offer the user a guided tour by authoring a guide and linking it to the form. Guides can be applied to other components as well, such as reports and widgets. In addition to services, BizDoc has built-in components for Angular, which can be embedded within forms and other Angular components. BizDoc Cube is the mechanism of indexing forms data into a table. Number 1, when a form is sent to root, the form data model gets analyzed. Number 2, relevant properties then are mapped to cube access. Number 3, data then is tabulated into entries of the cube. Note that each access is mapped to a type source. Once data is tabulated, we can access it in various views, including chart, pivot, or grid. There are more than a dozen of ready-to-use reports and widgets to show cube in various ways. We control these components by applying options in configuration file. Like other components, cube is backed by a server-side component. A cube component inherits from cube base. Once we created a cube, we need to specify which columns the cube will manage. These are called access. Each access is mapped to a source, such as accounts or years. Form models map to cube access using the cube mapping attribute. Cube database table can also be populated with data from third-party apps, such as POs on corporate ERP. A background task may update cube table directly with the third-party data. To enable drilling down into third-party system, Cube implements the iBrowsable interface. Cube can be accessed from both client and server side via one of BizDoc services. Cube can be queried using Cube service, viewed via Cube info, or accessed directly using the store service. BizDoc automatically configures components as we add them to our project. We then enter the configuration to apply settings. Configuration is saved in bizdoc.json file, located in project root. We can manually edit this file to change settings. For example, we can change a cube via chart type. Backups of the file can be found on /backups directory. BizDoc stores forms data in database objects. BizDoc own objects are generated and maintained automatically and located under the BizDoc schema name. Additional libraries may add their own tables. The database main object is document, which represents a single form. Each document may have one or more recipients, referring to the users who received a copy of it. As the document moves along route, document log objects keep track on occurrences. Log records state change, action taken, attachment downloaded, and more. We can access database objects in one of two ways: using the iDocument context service, which provide access to the currently executing document, or using the store service, gaining direct access to all database objects. Implementation may require custom database objects such as support tables and form data models. The approach we use is code first, by which 1. We declare classes that represents the tables we wish to add, and 2. We use entity framework migration to update the database. This way, moving the implementation from development to testing server will automatically update the destination environment. To add a custom store, declare a class that inherits from DB context and register it using startups.cs and add DB context. Use EF migration to apply objects definitions to database. BizDoc will update the database tables in addition to the JSON model kept internally. BizDoc extensively relies on background execution. Jobs execution and failures can be found in the URL/hangfire. Recurring jobs as well as custom jobs are registered on startup.cs. Finally, when moving to production, we will compile Angular using the build prod param to generate a reduced file size and publish our work using Visual Studio Publish Profile. Any database definitions will be applied using EF migration. BizDoc packages are regularly published to address new issues. Issues and discussions can be opened on GitHub.